Nowadays, we don't really think of gravity as a force anymore, but more of what it feels like when something massive, like this jar of marmalade, bends the stage of the universe, which we call space-time. But this very fabric of reality can be stretched and squeezed by cosmic catastrophes like black holes colliding, forming waves. These aren't pretend waves, they go through you and me, physically extending and contracting us. For instance, making the gap between this bridge of us slightly bigger and smaller in an oscillating wave pattern, from a bit like shaking a bowl of jelly. Isn't that insane? And using lasers you can actually see it. Now when these two beams combine over here, they create a unique pattern, and when you move the lasers, the pattern changes. Gravitational waves move these beams and thus change the pattern. Our setup here is far too small, so I'll use sound waves. Ha! The premise is the same. You see the pattern move, but they're both waves. And with big enough detectors and powerful lasers, you can actually see space-time warp. When spinning black holes collide, a wave can be generated that is so imbalanced that it can actually eject a black hole out of its own galaxy. Even more ridiculous, for a split second, the power of those gravitational waves surpass every single star in the observable universe by over 50 times. But absolutely anything that accelerates causes gravitational waves, including this plane. Now we can compare the ticks of signals we receive from special stars called pulsars, and when we see a tick that is delayed because a gravitational wave has literally stretched space, we can use that information to triangulate the position of where that wave came from in the universe. Just imagine what we could do with that information. And this is because these waves pass through everything, unimpeded, unaffected, which makes it especially useful for a new age of astronomy, where we can see events that have never been previously observed by humans. In fact, we're even able to observe back in time to the first heartbeat of the universe, a time where space was essentially opaque to light. An age older than even our Prime Minister. Gravitational waves allow us to listen to the universe in a way we never could before. And maybe, just maybe, they'll help us answer the biggest question of all. Where did it all begin?